Hi, chemistry. We're going to talk a little bit about the atom today. So we've moved on from our discussion on numbers and math and dimensional analysis, and we're going to start talking about the actual atom so that we can then apply the numbers and math and dimensional analysis to the atom. So we haven't gotten rid of them forever, but we're going to take a break from them and just look at the basic structure of the atom. Okay, so let's just start with what atoms are. They are the smallest building blocks we have of our matter. Matter, as we learned in our first unit, is defined as anything that takes up space and has a mass. Okay, we typically will measure mass in terms of grams, but when we talk about atoms, a single atom isn't going to weigh a gram. Remind you that a gram is about the mass of a paperclip. So if you can hold a paperclip in your hand, that feels like a gram. Atoms are way smaller than that, so we can't use the unit of gram. We're going to use something else. So what's an atom? Well, first and foremost, we generally talk about atoms as this electrically neutral substance. So here's what I mean by electrically neutral. They don't have to be electrically neutral. That's the most important part you want to remember. Sometimes we have different numbers of protons and electrons, and we call those ions. More to come on that later. We also have different numbers of protons and neutrons, and we call those isotopes. Also coming a little bit later. All right, so what are the parts of the atom? Some of this is going to be review. You have heard of protons, neutrons, and electrons. Yes, you really have. Okay, so a proton is going to be symboled with this little P with a plus sign. So if you ever see that, know that I am referring to proton. It's like my shorthand for it. So protons are located in the nucleus. That's the center part of the atom. Hint, that is a test question. Okay, they are positively charged and they have a mass of 1 AMU. Remember when I said that we don't use grams for atoms? We don't. We use AMU, which stands for, are you ready for this? Atomic mass unit. I know, super fancy, but that's what it means. And so protons have a mass of 1. You can never have half of a proton, so you will never have half of an AMU. It's always a whole number. The second subatomic particle we're going to talk about is your neutron. And I like to look at the neutron as an N with a 0. And it also tells me the word no. See how it says no? And that is telling you that neutrons have no charge. They are neutral. Okay? They are also found in the nucleus. So let's picture this. You have your positive protons with your neutral neutrons. See, even I make mistakes. When you put those together, your nucleus is a positive entity. Because your neutrons contribute nothing, no charge whatsoever. They're just there for mass, okay? So another really good test question would be, what is the charge in the nucleus? Well, considering there's only positive protons in the nucleus that have a charge, the answer is positive. So neutrons are neutral. That's where that sound comes from. Then we have our electrons. Electrons are going to be negatively charged, and our symbol for electrons is this little E negative symbol here. They are located in what we call the energy levels. Now, I've had a couple students say, isn't that shells? And it's not shells. Sometimes we talked about their sublevels as shells or the outermost shell, but that's really not what we call the region in which the electrons live. They live in what we call energy levels. Now, you're going to get a fancy schmancy periodic table, and your periodic table is going to look something, let's move this out of the way, like this. Boom, periodic table. If you look over at the side, you'll see 1, 2, 3, 4. See how it kind of goes in rows? Those are your energy levels. So your periodic table actually tells you your energy levels. It's really convenient, and it's going to be your friend. So let's go back to our PowerPoint here, now that you see a little bit more. Okay, so we have our electrons. They live in the energy levels, and they are negatively charged. Now, unlike the proton and our neutron, electrons do not contribute to the overall mass of the atom. Okay, and the reason for that is that they're about 2,000 times smaller. I mean, they're really, really tiny than a proton or a neutron. So when we talk about adding up the mass of the entire atom, the mass that is contributed from the electron is so negligible that it will not appear in your significant figures. Therefore, we completely ignore it. So when we talk about the mass today, we're only talking about the mass of the nucleus, which is protons and neutrons. All right, so really quickly, here's a review. Here's my symbol. Think about what subatomic particle is this? Where is it located, and what its charge? Take a moment. Okay, your protons, they're in the nucleus, and the charge is positive. Then you have your electrons, and the energy levels. Get used to saying energy levels. No other answer will be accepted. And their charge is negative. Then you have your neutrons, found in the nucleus, and their charge is neutral. All right, so the next thing you need to understand, and you might see this on a quiz or a test, is what we call the Z. Z stands for atomic number. So atomic number, and I'm going to jump back to our periodic table. Don't panic on me yet. Atomic number is this top number right here. So above hydrogen, I have a 1, and that is representative of my atomic number. Magnesium has 12, calcium 20. Okay, so that number above the symbol is atomic number. All right, so what does that mean? Well, your atomic number, or your Z number, is the same as the number of protons in the nucleus. When you look at the periodic table, you will find that no element will have the same atomic number as another one. That's because all elements are defined by the number of protons. You change the number of protons, you completely change the element. It is always a whole number because you can never have half of a proton. Okay, so let's talk about that fancy word called isotope. An isotope is going to be an element in a different form. So I have multiple isotopes of carbon. You may have heard of one. It's called carbon-14. And we use carbon-14 to specifically date different objects. So we'll say this is millions of years old because carbon-14 tells us. Well, carbon-14 is the name of an isotope. It gets its name from the mass number. Mass number is going to be represented by protons and neutrons. So I'm going to show you guys a picture of an isotope. Here's hydrogen. Hydrogen has 3 isotopes found in nature. I have my positive proton, and if I look at my periodic table, hydrogen is number 1, so that tells me there's 1 proton. Any more protons than that, it is no longer hydrogen. The second I add another proton, I now have helium. So 1 proton equals hydrogen, no matter what. Here I have 1 proton, 0 neutrons. Here I have 1 proton, 1 neutron. Here I have 1 proton, 2 neutrons. They're all hydrogen, but these are what we call different isotopes. Now remember, a proton has a mass of 1 AMU. A neutron has a mass of 1 AMU. So if a proton has a mass of 1 AMU, the mass of this isotope is 1. The mass of this isotope is going to be 1 plus 1, so therefore 2. And the mass of this isotope is 1 plus 1 plus 1, which gives you 3. So the mass of an atom, an isotope, an ion, all those different words refer to the nucleus. The nucleus defines mass. So, mass is the individual nucleus containing proton plus neutron, its equation is represented here. Mass number equals proton plus neutrons, and it will always be a whole number. So if I have 2 out of these 3 parts of the equation, 1, 2, 3. If I have any 2 parts, then I can solve for my unknown. You're going to need to do that on your homework. Okay, the last thing you need to understand for your homework is distinguishing between isotopes. And we do that using what's called a nuclear symbol. So let's review this whole process. Z stands for atomic number, the number of protons. Ta-da! Mass number is going to be A. Notice that this time it goes on top. This is different than what you would see on the periodic table. Again, the name of this format, this is called nuclear symbol. Okay, so your mass number gets A. And what's mass number? Protons plus neutrons. Finally, X is going to be right off that periodic table. That's the symbol on your periodic table. So, isotopes are atoms of the same element with different masses. So here's my example. I have carbon. If I look at the atomic number on the periodic table, carbon has 6 protons. And then I look at my mass number to figure out neutrons. So we name this isotope based on mass. So this is carbon 14. That's the name of this isotope. And it has 6 protons. So how many neutrons does it have? Well, I would take 14 minus 6, and that gives me 8. So carbon 14 has 8 neutrons. Down here, I have carbon 12. Again, you name isotopes based on its mass. So if it has 12 as its mass number, minus 6 protons, that gives you 6 neutrons. Okay, those are the main things that you need to know for your homework. Kind of breaking it down a little bit more, if I look at the periodic table, this number at the bottom, note it does not say mass number. That is different than average atomic mass. So for your homework, I want you to ignore this number. We will come back to that later. Then we have that fancy word called an ion. An ion is a charged atom. In other words, our equation is protons minus electrons. We're going to look at the 2 charged particles inside the atom. So, again, protons don't change. Protons have to stay the same. If I'm working with one element, I can never ever adjust protons. I can only adjust electrons to change the element's charge. So, if I have an overall negative charge, then my ion has more electrons. Remember, electrons are negatively charged. So if the overall structure as a whole is negative, then I have more electrons than I do protons. If the overall structure is positive, that means I have more positive protons than I do electrons. So I can look down here and I can see, okay, if my ion is negative, then I've gained electrons. I'm adding electrons in. If my ion is positive, then I'm losing electrons. These are the primary tools that you will need so that you can be successful in your homework. I will also be posting a video on how to do pen tables, so please refer to that if you need a step-by-step guide. Thank you.